So the next part of the overview, and I think I'm not sure if it's the last part of the overview, it's the next part of the overview, will show how to understand the different types of methods that appear in the CompletableFuture API. And as you can see, this pie chart breaks them up into 5 categories: factory methods, completion stage methods, basic methods, exception methods, and the weirdly named arbitrary-arity methods. First of all, why the heck do we have to break things up into 5 categories? Well, the reason is that the entire CompletableFutures framework resides in a single public class that has over 60 methods and about a dozen or so nested classes. So it is an absolute beast. If you really want to have your brain explode, go take a look at the source code for CompletableFuture, and it's quite the experience. Even looking at the CompletableFuture's web page for the documentation is daunting because there's so many methods. So it really helps to kind of get this bird's eye view of what's going on without getting lost in all the details. So that's what we're going to do first. Some of the CompletableFuture's features are very basic. So we have things like the CompletableFuture's the Futures API, cancel, is canceled, is done, get, 2 versions of the get, one that blocks, one that times out. Those are all pretty much implemented wholesale by the CompletableFuture class because it implements the future interface. So of course it has to implement those methods. There's a few little tweaks. We'll talk about join and complete and so on, but these are really the basic methods. And they're nice, but they're only ever so slightly better than the conventional future interface. So using them is really not much of a win. What's a win are the other more advanced features. So as you can see, there are some basic methods, but the bulk of the methods are advanced. So they do a lot more stuff. So my little analogy, you've got your simple table setting, and then you have your Swiss Army knife with all kinds of different features and attachments and so on. So there's a couple of different kinds of methods. There's so-called factory methods, and these are used to initiate 2-way or 1-way asynchronous computations without using threads explicitly. And they're relevant in the context of reactive programming because they help to leverage the pool of worker threads by making your programs more elastic. You can scale them up or down by creating threads in the background that run in parallel on the cores that you've got. There's also completion stage methods, which, as you can see, are the bulk of the methods. The majority of the methods that are in CompletableFuture are completion stage methods. And these chain together actions that process the results of asynchronous operations and help to compose them together in various ways. So there's actually an interface called the completion stage interface, which has a lot of methods. I just show a snippet of them here. And CompletableFuture implements completion stage as well. So it's got all those methods too. And it's definitely worth reading the documentation for completion stage. It's got some really good explanations of what these methods do and how they're used. Completion stage methods help to make your program more responsive by ensuring that user code is not blocked while long-running computations are processed asynchronously in pools of threads, or in a pool of threads. The next example of types of methods are called the arbitrary-arity methods, and I'll talk more about what an arity is later. You can take a look at this link. When we talk about binary, we talk about unary, we talk about ternary. That really just means how many arguments are passed. So arbitrary-arity means you can have an arbitrary number of parameters passed. And what these methods are used to do are to combine multiple futures, basically an array of futures, into a single future. And somewhat like the completion stage methods, these methods make programs more responsive by not blocking the user code. In fact, you can wait for sort of an arbitrary number of things to complete without having to block at your user code at all. It's really cool. And then the final types of methods are the exception methods. And as the name suggests, they're used to help handle exceptional conditions at runtime. They make programs more resilient by handling erroneous computations gracefully. So if something goes wrong in an asynchronous program, rather than having the whole program be corrupted or having the program crash or not knowing what to do, you can set these exception method handlers that work very much the same way that exception handling works in classic Java or C++ code, where you have try-catch blocks. You can have the control flow transfer, skipping over all the intermediate steps, to these exception handling methods, which then arrange to process the exceptions in a clean way. Okay, so that's the end of the overview. The key point I want to make here, just to underscore this, is that there are a whole bunch of different methods that exist in, let's see, let's go back to this one. There's a whole bunch of different types of methods, 60+ methods. Something like 40 of them are completion stage methods. 2 of them are arbitrary-arity methods. 3 or 4 or so are exception methods. There's 4 factory methods, and then there's the rest are basic methods. To understand this overall abstraction, you have to understand all these things, but it helps to break them up into chunks. And what we'll do next, after in the next class, is I'll start going through each of these categories of methods and explain them to you. So of course, we're going to start first with the basic methods, and I'll show you how they're ever so much better than using classic Java futures. Not a whole lot better, but a little bit better. And then we'll spend the bulk of our time on the completion stage methods. And those themselves are very complicated, as you'll see as we go through them next week. And you'll also see that because there's so many of them, they also can be decomposed into further categories. So we have some completion stage methods that are triggered when one previous stage completes. We have other completion stage methods that are triggered when 2 previous stages complete, both of 2 previous stages complete. We have yet other methods that are triggered when either of 2 previous methods complete, and so on and so forth. And so once you kind of have the bigger picture view in your mind about all these different classifications, you'll have a better idea, I think, of how they actually get used. And so when you do your programming assignment, it won't be this avalanche of strange methods, all of which look very similar. Like when you start looking at the completion stage methods, they're all like, then do something, then do something, then do something, then do something async, right? And so it starts to become a blur. So the good news is we'll go through all that stuff, and you'll have a much nicer understanding of how all the pieces fit together before you get lost in the details.